In this lesson, we're looking at not necessarily another form of a quadratic function, but it is another way that a quadratic equation could be solved. And so in example 1, we see that the instructions are saying to use square roots. And what they're wanting you to notice is on the left-hand side, if I leave that alone, on the right-hand side, this factors to x plus 7 times x plus 7, because factors of 49 that add up to 14 are 7 and 7. Well, this is x plus 7 quantity squared. So 25 equals x plus 7 squared. And now I can take the square root of both sides of the equation as a different way of getting x by itself. So when I do that, remember that this square root and this squared will basically cancel each other out, and conveniently here, the square root of 25 is 5, so plus or minus 5 equals x plus 7. And then, in order to get x by itself, I would subtract 7 from both sides, and that would give me negative 7 plus or minus 5 is equal to x. And in this particular problem, because the square root of 25 was a rational number, I can go ahead and simplify this further. And x equals negative 7 plus 5 is negative 2. Negative 7 minus 5 is negative 12. But what if the trinomial here wasn't a perfect square trinomial? In other words, what if it wouldn't factor to the same thing being multiplied together twice? Well, then what we do is called completing the square, where if I have an expression like this, I find a number to add to it so that it does factor to the same thing twice. In other words, it would factor to be, or rather it would create a perfect square trinomial. For example 2, part A, this is kind of an oopsie, my including this, because what I'm really doing here is I'm not going to end up being able to rewrite it like this, but this example, if you already took the notes using Savas, you would see that the magic number that I need to add on is always going to be b divided by 2 squared. So whatever this number is, I divide it by 2 and square it, and then I'd be able to rewrite the expression as a binomial squared. So we're going to apply that here. I'm going to move the 5 over and have x squared plus 8x, and then I'm going to leave a plus blank in the space where the 5 was. When I subtract the 5 over here, I'll have negative 5, and then I'm writing down a plus blank here also, because if I'm adding a number here, whatever I do to one side of an equation, I better do to the other side. And so, as I mentioned previously, the number that fills in this blank is b divided by 2 and then squared. So 8 divided by 2 is 4, 4 squared is 16, and if I'm adding 16 here, then I'm adding 16 here. So now this factors to x plus 4 times x plus 4, which I can rewrite as x plus 4 squared. And so please notice you don't have to go through this step every single time. If you're completing the square correctly, then it will automatically factor to the same thing being multiplied together twice. So how do I find this expression? Well, this term is always going to be the square root of this term. This sign will be the same as the sign of the middle term, and then this term is the square root of this term. So I simplify on the right-hand side, and I have 11. Now, back here, I went further because I was trying to find the solution. In this particular problem, they're not asking me to solve the equation. We'll do that in the next example. In this problem, they're just wanting me to get to this step. So that's my answer. In example 3, I'm going to start off the same way by bringing this loose number over to the other side. Now I have -3 equals x squared minus 2x, and then I have that plus blank because I'm going to add that magic number that's going to complete the square. And since I'm adding something here, well, I better have something here that I'm adding to it as well. It's -2 divided by 2 and then squared. No matter what, I don't care what your calculator spits out at you, this number is always going to be positive because you're squaring a real number. Okay, so do you really need to write the negative sign here? Not really. So -2 divided by 2 is -1. -1 squared is +1. I simplify and I have -2 equals, this is now x minus 1 quantity squared. When I take the square root of both sides, I have plus or minus square root of -2 equals the square root of x minus 1 squared. So here I have a square root of a negative. Hopefully you remember from the previous lesson that that means there's going to be an I in my answer. So this is plus or minus I radical 2 equals x minus 1. And then my last step is just to isolate my variable. That gives me x equals 1 plus or minus I radical 2. In this next example, we have a rectangular region. We have the perimeter and we have the area, and we're trying to come up with the best possible dimensions. Okay, so let's visualize this. The perimeter would be 2x plus 2y equals, the perimeter they gave us is 340. And then I know that the area of this enclosure is x times y, and that's 6,000. Well, I don't want to solve this as a system of equations. I want to write this as one equation. So that means I need to get one variable in terms of the other one. This is the easiest equation to do that for. So if I divide this whole equation by 2, I have x plus y equals 170, and so y is 170 minus x. So now I'm going to rewrite this area equation plugging in 170 minus x for y. So now I have x times 170 minus x equal to 6,000. So I'm going to distribute this, complete the square in order to solve. So this gives me 170x minus x squared equals 6,000. Okay, well, we want this in standard form so we don't accidentally divide by 2 and square the wrong value. This is negative x squared plus 170x equals 6,000. All right, but this negative sign is throwing a monkey wrench in my system. So I'm going to multiply this whole equation by -1 so that x squared is now positive. So x squared and then minus 170x plus the blank, because that's my magic number that I'm going to figure out, equals negative 6,000. So that magic number, remember, is going to be 170 divided by 2 and then squared. So 170 divided by 2, and then when I square that is 7225. And if I'm adding it here to the left-hand side, then I'd better add it to the right-hand side. By completing the square, this trinomial here can now be rewritten as a binomial squared. And it would be x minus this 170 divided by 2, which was 85, and then squared, equals, I combine my like terms on the right-hand side, so 7225 minus 6,000, and that's 1225. So now I can take the square root of both sides. X minus 85 equals positive or negative, well, it's the square root of 1225. Hey, that's convenient, it's 35. Then finally, I add 85 to both sides. So x is 85 plus or minus 35. X is 120, and 85 minus 35, or 50. Okay, so you might be thinking to yourself, well, how do I know which one is the right answer? Well, the problem is asking us for the dimensions. Well, if this is 120, then this is going to be 50. And if I chose this to be 50, then this would end up being the 120. So the bottom line is that since the problem was asking me what are the dimensions are 120 meters by 50 meters. In the next example, they're giving us the equation, so that's really helpful. And we've received $9,000, and we can use that to cover the costs. So the problem is asking us how many customers would we need in order to use all of that grant money. What you need to be careful of is that C is the cost in hundreds of dollars. So 9,000 is 90 hundredths of dollars. So I set that equal to x squared minus 16x plus 73. And then I'm going to solve this equation by completing the square. That means I'm going to subtract the 73 over first, giving me 17. And I know I'm going to be adding something to it, so let me go ahead and leave the space for it. Equals x squared minus 16x plus blank. That's 16 divided by 2, and then squared will be 64. Well, if I'm adding the 64 here, then I need to add the 64 to the left-hand side. This now gives me 81 equals x minus 8 squared. And when I take the square root of both sides, I have x minus 8 equals positive or negative 9, because 9 is the square root of 81. Okay, now if I add the 8 over, I'll have x equals 8 plus or minus 9. Well, if it's 8 minus 9, that would be a negative number. And in the context of this problem, that doesn't make any sense. So I'm only interested in the 8 plus 9, which is 17. So 17 customers is how many it would take for us to use all of the grant money. Okay, so I mentioned earlier that this isn't really a different form of a quadratic function, but what it does allow us to do is to rewrite an equation, for example, here in standard form, we can rewrite it in vertex form by completing the square. Okay, so we have y equals, oh no, there's this -2 kind of messing around with our works. So what I'm going to do is factor that -2 out of my first two terms. So that'll be x squared, then minus 5x, and then plus blank, because I'm going to complete the square inside of that parentheses. And then don't forget the +1 here. I still need to have it in my equation. I can't just get rid of it because it's annoying. Right, so a little bit annoying here. I need to divide an odd number by 2 and then square it. Okay, so that's what calculators are for. 5 divided by 2 and then squared is 6.25. But now, please notice, I added 6.25 to complete the square, but I added it inside of a parentheses that's being multiplied by -2. So what I've actually done here is subtracted, well, what's -2 times 6.25? I've subtracted 12.5. Okay, so previously when we were completing the square to solve an equation, whatever I did to one side, I just did it on the other side in order to maintain balance. Well, here, since I'm not wanting to add stuff over to this side of the equation, because then I'll just have to bring it over, instead, I'm going to do the opposite. Okay, so what I just did here was to subtract 12.5. So to balance that out, I'm going to add 12.5 to the rest of the equation in order to maintain balance. Okay, so now this is y equals -2 times x minus 2.5 squared plus 13.5. Well, now that it's in vertex form, my vertex is staring at me. My vertex, remember, is h, comma, k. So my vertex is 2.5, comma, 13.5. And so the problem is asking me for the maximum or minimum value. Since my a value here is negative, I know that this is going to be opening down. So this graph has a maximum value, and that's the 13.5. And then in order to graph this, let's make my x-axis go by, I'm going to make everything go by 2s. So 2, 4, 6, 8. And then my y-axis also 2, 4, 6, 8, 10, 12, and 14. The reason I'm doing that is because if I had gone by 1s, I'd run out of space on my y-axis. Okay, so my vertex is at 2.5, comma, 13.5. So that's about here. And remember that when the equation is in standard form, our y-intercept is kind of right here staring at us. So I can see that my y-intercept is going to be 1. And then finally, remember that this axis of symmetry means I have another point just like this to the right of this axis of symmetry. Okay, so this is 2.5 to the left, so I'm going to go 2.5 to the right of here, which is going to be 5, comma 1. So here's my very badly drawn parabola. But as you know me, this is what a graphing calculator is for. This is what your brain is for.